So point slope form, remember, it's the form of a linear equation that we use when we know or can calculate a slope and we have at least one point that the line goes through. Usually this is kind of just a starting place for us, and we're gonna solve and put this in probably usually slope intercept form. Right? This is where we would start plugging in the information, and then once we get the information in there, we could just isolate y and simplify, and that automatically puts us into slope intercept form. So here's the example that we looked at on Thursday. Let's just kind of rehash this one. So if we know we've got these 2 points, instead of them giving us a slope directly, if they give us 2 points, well, we could calculate a slope, right? And that's just one additional step that we added. So if we take these 2 points and we calculate a slope, we could do the second y value minus the first y value divided by the second x value minus the first x value, which gives us, when all the dust settles, we got -5/2 for our slope. Now that we have a slope, we know where that goes in point slope form. Oops, that goes in for m. And then we need to pick the easiest of the points that we have available. And sometimes it's really not much difference. In this case, it doesn't really matter. So we picked, in this case, they picked -6 and 8 to be the values of x1 and y1 that we're going to plug in, the coordinates. So we get our slope we plug in for m. We're going to plug in -6 for our x value, so we get x minus -6 gives us x plus 6. We're going to plug in +8 for our y value, so we get y minus 8 equals -5/2 times the quantity x plus 6. Then what? If we want to simplify this and put it in slope-intercept form, it's always the same. We distribute the slope and add 8 to both sides, to isolate the y and combine like terms, and we're done. No big deal. Okay, but where we want to go, the last couple, these are the kinds of questions you're going to get on the homework. Okay, stuff like this. Well, then maybe you're just a little bit trickier. So these are all coded versions of the same question, but sometimes you have to be a little trickier to extract the information. What are the pieces of information that we need for the point slope form of a line? Well, we could have 2 points, but all we really need is for the point slope form is what? It says it right in the name. I need a point and a slope, right? And that's it. That's all I really have to have. In the last situation, we got it from 2 points. We extracted that information from 2 points. In this case, we're given some different information. Now let's read through this question. It says, write an equation in slope-intercept form for the line that passes through 6, 8. So what's that? There's a point on our line, okay? Perpendicular to the line y equals -2x plus 5. Where's the slope? Say it again. Not close. 1/2. Who said 1/2? How'd you get it? Kelly, how'd you get it? There you go. Okay, so here's the key. So now we're dealing with 2 different lines here, aren't we? Right? We want to write the equation for a line that's perpendicular to this other line. So this is not our line, right? It's just a line that's related to ours by the fact that it's perpendicular to ours, right? So if the slope of this other line here, if the slope of this other line is -2, and we know that our line is perpendicular to that line, perpendicular lines have opposite reciprocal slopes, right? So our slope is going to be the opposite reciprocal of -2, which is 1/2, right? So then we've got our slope, we've got our point. All we've got to do is throw that information into the point slope form and plug and chug, and we got an answer, right? So we start off with y minus y1 equals m times the quantity x minus x1. We plug in our information. So what's y1? 8, right there it is. So x1, y1 are just the coordinates of the point that we are using, right? So we get y minus 8. So Jordan, what's our slope? What am I plugging in for m? 1/2. Good. And then all we have to do now is plug in our x coordinate. What's that? There we go. Okay, so there's our line. When you get to calculus, you'll be able to just leave it like that. But for now, we got to finish this, right? We got to simplify it and put it in slope-intercept form. So what are our two steps? Distribute. If I distribute the 1/2, I get y minus 8 equals what? Good. Last step. Add 8. So what is that? 5? Okay. Make sense? Okay, how about something like this guy then? Now this is even trickier. Okay, so this time it tells us write an equation in slope-intercept form for the line that passes through the point 64 parallel to the line that passes through the points -9, 8 and 9, -4. So does our line pass through either of those 2 points? Probably not, right? It doesn't tell us that it does. These are points that define some other line that's parallel to our line, right? So what's our strategy here? We just need a point and a slope. What do you think? Okay, so let's calculate a slope. This is going to be the slope of the other line, correct? So the slope of the other line, and I'm just going to do it that way. The slope of the other line is going to be what minus what? Somebody help me out here. What minus what over what minus what? So say it again. 8 minus -4, that's fine, divided by, okay, good, very good. If I'm subtracting the second value from the first, for the y's I have to do the same thing for the x, right? So I get -9 minus 9 then. And what's that going to give me? On the top I get 8 minus -4 is, on the bottom, -9 minus 9 is? Good. Now the sign, if I have a positive over a negative, what's the overall sign? Negative, so we'll put the negative out front. 12 over 18 reduces to 2/3. So the slope of the other line is -2/3. If our line is parallel to that other line, what's our slope? -2/3. Parallel lines have equal slopes, right? So our slope is equal to -2/3. Our point is 6, 4. There's everything we need, right? So now I would just plug that stuff into point slope. Y minus, what's y1 going to be? 4 equals m times x minus, what's my x1? There you go, right? Now all we have to do is just distribute the -2/3. So I get -2/3 x what? Plus 4, good. I add 4 to both sides, and so I get -2/3 x plus 8. Okay, make sense? Okay, so it's the same thing, isn't it? The information is just coded in a tricky way, but they're still kind of covertly giving us a slope and a point, aren't they? Okay? All right, so what about, last little bit here, what about some some equation applications? And there's 2 different kinds. Now I just want to maybe just do one today, and we'll come back and hit this again tomorrow before we jump into the assignment. So they give us some information. It says a cab ride costs $4 plus $1.75 per mile driven. So the first thing says, now it says write an equation to represent the cab fare, where we've got to define some variables. So we don't want to get specific yet. We just want to write some linear equation that's going to represent our overall cab fare. Okay. Now, when you get these assignments in Moodle, I'm going to tell you what I want the variables to be, so you're all on the same page. But here we'd have a little bit of freedom to define the variables as we want them to be. What are the variables going to be? Okay, y. We could have y, but we could also call it maybe like c for cab fare, right? And then what else? So that's going to be the output variable, isn't it? The overall cab fare. What's our input variable going to be?
M for miles.
M for miles. Okay. And then we just want to come up with an equation that's going to give us cab fare as a function of miles. So C as a function of M.
So
I heard lots of them. Okay, so I heard C equals, how do we describe this for?
That's the y-intercept.
Starting value, okay, so that starting value is the same as the y-intercept, isn't it? So that's gonna be M or B in this case. It's gonna be B, isn't it? Okay, plus $1.75 per mile driven. What's $1.75 here? Slope. How do you know it's a slope? 'Cause it's a rate. It's a per, right? It's a rate. We've got dollars per mile, right? So that's gonna be the slope. And we're gonna, if we wanna know, we wanna break this up into two parts. We're gonna multiply the slope in this case by the input value, which is what? Input variable. Which is what? Output variable is cab fare. What's the input variable? Okay, so there's the answer, isn't it? Now, I want to go one step further though. Let's look at this in terms of each of these two terms has some meaning. What do they mean? The overall cab fare equals the 4, you told me it's the start value, right? So we might even call that something like the fixed cost. So if you're gonna get a cab from this company, you always you have to pay $4 no matter what, right? That's just kind of an upfront fee, a constant fee. So we could call that, instead of a start value, we could call it like the fixed cost. Or the fixed, well, we don't want to say rate, right? It's really a fixed cost here, because a rate would confuse it with a slope. So it's a fixed cost in this case. Does that make sense?
Yeah.
Now what about this other part here? We got this plus sign in the middle that's separating the two terms. And then this other part, right there, 1.75 times M. So that's the rate times the input variable. What is that going to give me, though? How could you describe what that term is telling me in this equation? How does it contribute to the overall cab fare? Okay, so like the cost per mile times the number of miles. So what could we call that? We could call that the mileage cost or something like that. Does that make sense? So this is the part of the fare that you're going to pay that depends on how far you drive. This is the part that is the same for everybody, right? No matter how far you drive. Does that make sense? Okay. So there's our function. Now, if Clay's destination is 17 miles away and he has $30, is he going to make it? How do we know? Plug it in. Okay, so if he's 17 miles away, we could plug in 17 for M and just see what we get, right? If it's a number bigger than $30, then he doesn't have enough money, does he? Right? The fare's too big. So he's kind of out of luck, isn't he? If we plug in 17, we get 1.75 times 17 evidently is 29.75, plus 4 is 33.75, $33.75. He doesn't have enough money for the fare, okay?
I guess you should just walk a couple miles.
Even walk the
Okay, so now, here's kind of where I just want to end this for today. I just want to get you kind of, the more times you think about this, the better you get it. So we'll come back to this, but I want to give you a day to kind of embed this in your brain, and we'll come back and go a little further with it. Come on, there we go. Okay, I want you to compare that to a problem like this one. And we'll come back to the other one tomorrow. This is a little bit different, isn't it? Right? So Josh bought 3 bags of potting soil and 10 bags of mulch from Home Depot. Write an equation to represent the total cost. The total cost. Okay, so what would our variables be? We got to say total, like C might be like total cost, or T is in this case, right? T is total cost. Okay, but what do they mean by P equals potting soil and M equals mulch? What about it? P is maybe bags of potting soil and bags of mulch. Aren't those the variables, right?
Yeah.
Think about the ways that you could impact your final cost. What could you do? It depends on how many bags of each you buy, correct? Okay, there's the question. Yeah, if we know that he's buying 3 bags of potting soil and 10 bags of mulch, what do you think? What do those really mean? What are potting soil? That's not very descriptive. We should improve that definition of that variable. What is it really?
Bags is fine.
The cost for one bag. Cost per bag, isn't it? Right? So really, we should add some stuff to that. That's not a very good description. potting soil, it's the cost per bag. And for mulch, same thing. It's the cost per bag. And then, this makes sense as an equation, doesn't it? Right? The total cost is going to equal 3 bags of potting soil times the cost per bag. Make sense? Plus 10 bags of mulch times the cost per bag M. And so once again, if we break this whole thing down then, what do each of these two terms mean here? And I want you to kind of see something that's really important in math when you build mathematical models like this. And these are relatively simple models. They're just linear functions. But we'll move on into more complex functions as the year progresses. But I want you to notice something. A lot of times when you're building functions that we'll later talk about as being polynomials, for now we're not going to really have to worry about it that way. But a lot of times when you add up separate terms in a model, each term has its own specific meaning, which is a useful way to look at it. So how could we describe that 3P? What is that? 3 bags of potting soil, and P represents the cost for each bag of potting soil. So what is 3P then?
3 times the cost of a bag.
Okay, yeah, but I want you to summarize that. Okay, so it's the cost of the potting soil, right? The total cost of just the potting soil, right? So that's the cost of the potting soil. How about the 10M? Yeah, that's the cost of the mulch. We had 10 bags of mulch, and each bag cost M dollars. So doesn't that make sense then? Whoops, I did spell that right there. Not too bad. So look at this. Now we've got, that makes sense. We broke this down into the cost of the potting soil plus the cost of the mulch equals, no surprise, total cost, right? So how about this second one here then? If we know that Josh spent $40.91 and the mulch cost $2.75 per bag, how much was a bag of potting soil? So what does this represent, $40.91? T, good, total cost, right? So there's a value of T. What does the $2.75 represent? Mulch, okay, good. So that's M, isn't it? Okay. And if I plug those things into my original equation, let's see what happens. If I plug those into my original equation, I get 3P plus 10 times 2.75, right, equals 40.91. Okay, this takes us back to Unit 1. How many unknowns are there in that equation? So if there's one that we can point to, we can isolate it, right? All we got to do is simplify and then isolate P. And what would that look like? Just like that, right? 10 times 2.75 is 2750. So 3P plus 2750 equals 40.91. I'm just going to subtract that away and divide by 3, and I'm done, right? That's it. Make sense?
Yeah.
Okay. I'm going to call her quits. Let you work. We'll do a couple more examples tomorrow. I'll have another assignment for you.